Welcome, everyone. Thank you for joining us today for this exciting webinar from SiliconTech on building AI engines on AWS. My name is Will, and I'll be your host for this session. Whether you are an AI enthusiast and a cloud developer or a business looking to integrate advanced AI solutions, this session is packed with valuable insights and practical tips. I'm thrilled to introduce Marcelo, our expert speaker for today, who will bring his expertise in AI and its use on the AWS cloud. Before we start, let me remind you that you can share your questions over the chat and that you can get in touch with us after this presentation, and we will be more than happy to assist you. Without further ado, over to you, Marcelo.
Thank you. So let me quickly share my screen. All right. Okay. Hello, everyone, and welcome to this session. Today we will explore how to create intelligent agents that can understand, reason, and act to your business needs. This is not like an old chatbot with set rules. This is supposed to understand what the user wants and act accordingly. I'm Marcelo from SiliconTech, and I'm happy to share with you with these powerful ways to leverage these capabilities that AWS gives us. Today, we are going to talk about a bunch of things. So let me quickly walk you through what we will cover. We will start with an introduction to AWS Bedrock agents, why they are game changers. Then we will go into knowledge bases and RAG, which is crucial for giving your agents access to your business data. We will also explore how to build workflows visually, and I will show you how to make these agents accessible through WhatsApp in this case. For that, we are going to be using Vonage, which is a great way to use any kind of communication capabilities and very easily for a developer. Throughout the session, I will demonstrate these concepts with real examples, and we will wrap up with question and answers where you can ask about your specific use case. But as Will said, during the presentation, you can write your question in the Q&A section, and we'll read it and we'll try to answer it. Okay, so why agents matter? Why are agents becoming crucial in today's business? Traditional applications often hit a wall when it comes to understanding what the users really want. They struggle to understand context, and they can't easily tap into company knowledge. All companies have a lot of information, but that is completely unknown to these chatbots that we are using nowadays. So what we have right now is rigid, and the responses are like one size fits all, which is not what we want. So this is where AWS Bedrock agents come in. So they are like intelligent assistants that can understand context, access your company's knowledge securely, and provide consistent, personalized responses at scale. So they are not just chatbots, they are sophisticated systems that can integrate with your business logic and your processes. So what makes this particularly exciting is how it transforms the customer interaction. Whether it's customer service, data analysis, or process automation, and these agents can handle complex tasks while they're keeping always the human touch in the communications. Sometimes you forget you are talking to a machine. So let's talk about knowledge bases. This is pretty new. Well, everything regarding generative AI is pretty new. In the last couple of years, we have seen a lot of advances, particularly in Bedrock, which is this service that AWS has. Now is fairly easy to integrate RAG. Before, you had to program it piece by piece. You had to be aware of what kind of database you use, how to exactly perform the embedding, that is converting text to vectors, to numbers, and then how to retrieve that. So that has changed thanks to knowledge bases in Bedrock. So at its core, this is about making your AI agents smarter by giving them access to your organization's information. RAG, uh, that means retrieval augmented generation, is the secret sauce here. So instead of hoping that in the training information that the LLM had, there was something about your company that was picked up by Google or something, no. Here you make sure that the model knows about your business and has the information updated. So think of it as giving your agent a specialized library of all the company knowledge that you want to share. What is exciting about this is how flexible it is. You can input various types of documents. You can put PDFs, web pages, and Bedrock automatically processes them into a format that AI can understand using these vector embeddings that I was mentioning previously. So it works with multiple foundation models like Claude, Titan. Titan is the one from Amazon and others. So you can choose what works best for your needs and for your budget. Each LLM has a price or a cost, and you can choose for the specific task a model that fits your needs. So the real magic happens here when the user asks a question. The system finds the most relevant pieces of information, of data, and then uses them to generate accurate contextual responses. And importantly, it can cite its sources. So you always know where the information came from. This is not the hallucination that we were seeing all over the place with ChatGPT. This is exact information. This is very precise, and it can tell you exactly where did it come from. So what are the features of these knowledge bases?
Sorry, Marcelo,
Yep.
before
Yep.
you move forward, there's a question for this use case. So could you please tell us what are some examples of document types and formats that can be ingested into the knowledge base? Like are there any size limitations that we should be aware of?
Okay, so you can add many types of files to knowledge base. Yeah, you can add PDFs, Word files, web pages, text files, Markdown files. Each file, for it to work better and faster, it should be like with a maximum of 5 MB. But this is a recommendation. You can use bigger files, and then the system is going to break them down in big documents into smaller pieces, which are called chunks. And you can adjust that. So it's pretty flexible. In summary, you can use pretty much any kind of document that you already have. You don't have to convert files for this.
Great. Thank you, Marcelo.
Okay. So let's look at how these knowledge bases work in practice. When you feed documents into your knowledge base, AWS handles all the heavy lifting. It automatically breaks down your content into meaningful chunks, creates vector embeddings, and these are like digital fingerprints of your information. So they are stored in a space of many dimensions, and you can then find them easily. What's particularly powerful is how this scales. where you're dealing with a few documents or thousands of documents, the system maintains fast and accurate retrieval. The vector search technology means your agent doesn't just match the keywords. It understands the concepts and the context. For example, if someone asks about your company's refund policy, the system doesn't just look for the word refund in it. It's not case sensitive. It's not a simple search as we were using in the past. So the system is going to understand what you mean, and it can relate to another similar concepts like returns, guarantees, customer satisfaction. This means that your users get comprehensive, accurate answers, even if they don't use the exact terminology from your documents. This is game changing for many applications, from customer service chatbots that actually understand your policies to internal tools that can help employees quickly find and apply company procedures. Then we have flows. We are going to show a little bit about that later. This is one of the most exciting features of Bedrock. This is fairly new as well. And this is a visual workflow builder where you can take knowledge bases and more things and turn it into dynamic processes. So flows is like a visual programming environment, but it's specifically designed for AI workflows. So instead of writing complex code, you are connecting building blocks that represent different capabilities. These blocks or nodes, as we call them, can be prompts, knowledge-based queries, custom lambda functions. What makes this powerful is how intuitive it is. So you can draw connections between these components to define how the information flows through your application. You want your agent to check a knowledge base before responding, just connect the node. Do you need to add some business logic? Just drop a lambda in the middle. So the system also includes a built-in version control. So every time you make a change, you create a new version. This means that you can safely experiment with improvements while keeping your production version stable. That's important. You can even use aliases to manage different environments like development and production. We're going to see a little bit more when I share the demo, but now we can see what it looks like. You see this page with this visual editing part here when you drop the different nodes and you connect them, and you can then also configure each one of them in detail. You have different kind of nodes, as you can see there. You have the input node, and that takes your data into the flow. You have the output node that returns the final result from your flow. You have also condition nodes to make like if then decisions. You have the iteration node that loops through items in a list. You have a collector node that gathers all items from a loop that comes from before and gathers them into a list. You have a prompt node that is where text that is entered there is processed and sends to AI models, the AI models that you choose for that specific task, and send it back to the next part in the flow. You also have the agent node that use Bedrock agents to complete tasks and knowledge-based nodes. You also have S3 storage where you can save data to S3 retrieval, where you can get data from S3, a Lambda function, as I mentioned before, that runs custom code, any code that you can imagine, you can run it there. You have the Lex node, which calls a service, Amazon Lex, it was useful for a while for chats, and this is for certain applications. This could be faster and cheaper than using a prompt node. Perhaps you need a fairly simple classification task based on a text that the user enters. Instead of taking that information, put it into a prompt and send it into an LLM, you can just use Lex that is going to do that quicker and cheaper. So you have these flows help you build AI apps by connecting different tools together, like building blocks, as I said. You can have multiple AI helpers or agents working together. This is a nice way of orchestrating different agents. Until a few months ago, this didn't exist. And if you wanted to orchestrate different agents, you needed to program your Lambda functions or step functions. Here you can do this in a very flexible and easy way. So you can have, for a simple example, you can have an agent in AI that is good at math, working with another agent that is good at writing. There I have another agent that is good at talking to the customer. And so you see that setup is easy to do just using this visual drag and drop tool. And you can make your app use these AI flows with just a few lines of code. From your code, from your external program, that could be anything that you are used to programming, you can call these flows. You can either invoke the agents directly, or you can invoke these flows, and these flows are going to trigger all these processes that you have defined. Okay, so let's look at these components and how they work together. When you're building a workflow, you're essentially creating a decision tree for your AI agent. So each node in your flow serves a specific purpose, whether it's understanding user intent, retrieving information, or formatting responses. One of the most powerful features is the ability to add guardrails. You can do this also at the agent level. So as you can see, this is super flexible, and you can do this. You can utilize the different features like knowledge bases at the agent level only, or also at the workflow level when you have more complex business logics that you have to comply with. So these guardrails that I was mentioning, they're like safety checks that ensure your agent stays on track. For instance, you can add content filters to prevent inappropriate responses, or validation steps to ensure the answers meet your requirements. Also, what is important is that you can test all of this. The testing capabilities are useful, very useful. So you can test your flow at any point, seeing exactly how your agent will respond to different inputs. So there's even a tracing feature that shows you the path your data takes through the workflow, making it much easier to debug and to optimize your agent's behavior. So what's really exciting about this is how this or can be combined with prompt engineering. So you can fine tune how your agents interpret requests and how they interpret that and convert it into a response. So always maintaining the consistency through your knowledge-based integration. This is great. So if you had to manually program something like this before, so you know that making this backend is not easy. Now it got much easier with this tool. Okay, and for visualizing this, the output of this can be anything. For this specific case, we chose WhatsApp integration, which is a common thing that a business can implement, a WhatsApp bot, so their users can just chat on their mobile devices and get the, the proper answers. So let's talk about how you can make your agent accessible with this tool. So I will show you the complete flow. This starts with OneEdge, which provides the WhatsApp connection. There we configure a webhook that points to a Lambda function. And when the user sends a message on WhatsApp, OneEdge receives it and immediately triggers our webhook. The Lambda function acts as the orchestrator here and receives the incoming message from OneEdge, the webhook, and processes and invokes the agent. Once the agent generates a response using the knowledge base and workflows, the Lambda function takes that response and sends it back to OneEdge, which delivers to WhatsApp. So this serverless architecture with Lambda means we don't need to maintain any servers, and we only pay for the actual use. You use, of course, all the security features that Amazon offers, the IAM roles. So you ensure that you have a secure access to the services and between Lambda and Bedrock, while OneEdge handles the WhatsApp authentication and encryption. That makes sure that all the way all the messages are secure and there cannot be any security leak. So that what makes this powerful is how seamless it is for the end user. They just see a normal WhatsApp chat, while behind the scene we are using all these sophisticated tools. Okay, this is basically what I just mentioned before, from the user to WhatsApp, the API, then the API gateway in Amazon connected to the Lambda function, from then invoking the agent that is going to decide which knowledge base. In this case, for the demo, I put two different knowledge bases, so the agent has to choose depending on what the user asks. Um, all of this, as everything in Amazon, can be monitored. There's a service called CloudWatch where you can see all the logs on what is happening, and you can easily troubleshoot any problem that you encounter. So okay, now comes the exciting part. Let's see all this in action. I already set up a complete environment that demonstrates these concepts working together. So first I will show you how the knowledge base contains some sample business documentation. Then you can see how the information has been processed and how it's ready for the agent to use. And next I will give you a quick look at our workflow in the Bedrock console, see how the nodes are connected and how they work before generating a response. And then in WhatsApp, you see the end result. What are the responses this agent is sending to the chat, depending on what the user enters. Okay, let me share. Okay, here we can see in my Amazon console. Do you see it correctly?
Yes, looks good.
Okay, excellent. Here I can have it in there. This was pre-made, like in the cooking shows, because sometimes with the internet connection it can get uh, pretty slow. So you can see the important part, which is how everything is built and configured. For the knowledge bases, you have different ways that you can create knowledge bases and different data sources. For this case, I chose S3 buckets. And so I have two different buckets that are going to be used for two different knowledge bases in Bedrock. And each of them have the relevant documentation. This can be updated at any time, and this is synced on Bedrock, and it is always up to date. Let me check here on Bedrock. Okay. Let's do this. This is all modular, so you create the knowledge bases in one part and you can use them on the agent section, and you can also call those same knowledge bases from the workflow. So it comes pretty handy because you build things once and you can use them in many places. Here in knowledge bases, for instance, I'm going to show you how you create them. I have two that are already created here. But what it's going to ask you is basically for the name, then you define which data source that you can use. You can, as I mentioned, it can be an S3, it can be a website. So this tool is going to automatically scrape that website and get all the information as knowledge. You can also connect Confluence. If you have all of your documentation in Confluence, you don't need to scrape or download that. You can use that directly. And okay, and you also have to define which vector store you are going to use. What is a vector store? It's a database that is going to store those vectors. There are many possibilities here. This has existed for a while, but there was a proliferation because of the availability of these models of options. You can use the preferred way by Amazon, which is Amazon Open Search, which is a database that works very well for big enterprise solutions. But for many solutions, the option of using Aurora with BG Vector, which is Aurora database, is an RDS, is a relational database that has an extension where you can use it as a vector store too. And that's a nice way of implementing this quickly. And it is also serverless. This is what we use for this demo. And I created here two knowledge bases, as I mentioned before. Both of them each are pointing to one specific S3 bucket in the Amazon account. One of them has business documentation for Circontech. It has a business presentation. And the other one has poems about Circontech. I asked an LLM to create a bunch of poems about Circontech in order to differentiate that from business information and put that on a knowledge base. Then I connected that to the agent. So when you ask the agent, you can ask a business related question and you can ask, do you know about a poem about Circontech? So the agent has to make the decision, okay, where do I look for this information? In this knowledge base or this other knowledge base? So I'm going to show you how that decision works, how it looks like in the traces. Let's see here. This is the agent, which is already prepared and connected to the knowledge base. As I mentioned before, for the flows, a similar thing happens with the agents. You can manage versions, so you can make sure that you always are working with a stable version. If your applications will point to a specific alias that is connected to a specific version. So even if you make changes after that, they are not going to break your existing information. Okay, here I issued a question to the agent. The agent looked through the tools that he has available. He saw that he has two knowledge bases and decided that he's going to use the knowledge base that has the business information. So based on the query, what is Circontech, and looking at the information that it has, okay, it will answer with all the things that Circontech can do. What is nice here is that you can see exactly what happened behind the curtain. You have different traces that will show you what information was exchanged, what prompt what was used. There are a bunch of prompts that are already predefined here in the tool. You can configure them here. And you can also have, this is a new capability that came up this week, where you can test different prompts against each other, so you can quickly choose which one is better. Okay, this is a long trace. This is pretty difficult to see. I put it here just so it's easier to summarize what is happening. So for instance, when I made the question, what is Circuntech, what happened? The AI assistant checked the memory for the information, made a knowledge base query about the question. Then it decided which knowledge base is the best for answering that, then returned the information here, and it passed all the information to another part of the agent that interprets that and reads that and creates a message that is nice for a human to read and to understand. So this assistant analyzes the search result and create a response that is structured in a way that can be easily understood. And the nice part is, if you make a second question now, these are the traces for a second question, you see the same. What is Circuntech? Here I ask the LLM, do you know a poem about Circuntech? Then why is this here in the trace? What is Circuntech? Because the agent has a memory, and the agent, you can configure the amount of days that you want the agent to have memory for, and it will remember all the interactions that you had. So it has a better context of what is happening. So it doesn't only act on the current question, it also has knowledge of what happened before in that conversation. So when you ask about the poem, then it decides there is another knowledge base that it has to be used. So it found these several points here, and it provides an answer. Okay, so going, let me quickly show you the flows. Okay, here is a test for flows when you use several prompts that are united into one. For instance, this prompt, the user says something, okay? So from what the user says, this specific prompt is programmed to take that information and understand one activity that will be closely related to what is mentioned. There's something that the user wants. This other prompt is going to try to extract a country that is related to what the user said. And this other prompt is going to unite those parts, and is going to present an activity that can be done in some place related to what the user asked for. So to put it into an example, the user can say, okay, I like flowers and I like the cold. Then this flow is going to create a recommendation based on that. But inside, what happened was that one prompt extracted the activity, another the place, then this other prompt united. So let's see if we can do it. Okay, so I just said that I like flowers and clear water beaches, and then this flow, after all that happened inside, issued a recommendation of visiting a specific beach in Florida where I can enjoy the beaches and also to see native flowers. There are the sunflowers and railroad vine along the coastline. You see also this format. This is going to output the text on a JSON format if you ask for it, or in different formats. That is something that can be programmed in each of the prompts or in the outputs and can be tuned as long as you advance in your workflow. So I think I pretty much told you about the most important things about Bedrock. One important part is the quotas that you have for the different LLMs. This is important when you design these solutions. I will show you this interaction in WhatsApp that I haven't prepared already because it could get very slow with my bad internet collection. Um, so when the chat starts, the user asks, "Okay, can you tell me what Circuit Tech is?" So based on the results, Circuit Tech, it says this is all the business information that it got from the knowledge base, and that contains the business information. When you ask about the poem, as we saw before, it's going to answer about the poems that are extracted for this other knowledge base that it decided to use. When I ask about the limits, okay, I cannot ask about the limits, but I asked this question because I knew I was going to be hitting a limit. And this is why I see this error, this processing error. I can see this is a specific message because it is something that I programmed into the Lambda function that creates this message. Then when it gets an error from Bedrock to show it as it is. What is this about? In Amazon, you have service quotas for many of the services. You have limits that are set by default. So if you know what usage you are going to have for a specific service, perhaps you will have to ask Amazon support for an extension or an expansion on that limit. In this case, for Bedrock, you can see that different LLMs have different quotas that have for default, and some that are applied at account level. And this can be changed if you talk to your support representative. Okay, I think I pretty much covered it all. This is a standard, the API gateway that we use for the communication. This is the backend of the bonnet for the communication with Slack. Everything happened here, and this is this API address that we use for the communication as a webhook. Let's see. Okay, the last thing. The observability that you have for it all, you can always see CloudWatch, all the logs, where you can see not only what is happening with your API or your Lambda and what errors you have in your code, but you also have different metrics. Okay, this is an example of the log for this interaction. And you also have metrics for the calls that you are doing to Bedrock, so you can see how the invoke to the flows or to the agents are, how many you're reaching. If you are hitting any limits, then you can go to support and ask for an expansion. Check.
Amazing. Thank you, Marce. I think we have a couple of questions
Okay.
that to share with you. So the first one is after you show this WhatsApp integration, what about the data privacy and compliance? How does Bedrock handle sensitive information in both the knowledge base and during WhatsApp integrations?
Okay, so for privacy, the AWS keeps your data safe in two main ways. It encrypts data when it's stored and when it's being sent. So you control who can access through your AWS permissions. And these models are not being trained on your data, and these are inside of your account, and your data remains there too. Uh, in addition to that, you can add filters to protect sensitive info. And okay, and for the case of WhatsApp, the WhatsApp messages are always encrypted. Um, yeah, I think your data is pretty safe from end to end.
Amazing. We have one more question before we can close the presentation. What factors should be considered when generating embeddings? Specifically, do different models require unique embeddings, or can the same embeddings be utilized across multiple models?
Okay, there are several things that you need to have consistency, because when you are creating an embedding, you are creating you are storing information in a vector space of many different dimensions, and also the way that you use to get that text into a number might differ from other to another. So in order to have a consistency, and to at the time of the retrieval to find the information correctly, I recommend that you are consistent in the model that you are using, and also in the vector store that you are using. But also when storing the vectors, for instance, when you saw that I created two knowledge bases, they were not in the same database or in the same place. They were in different tables. If you can do it in the same table, but somehow you have to also indicate which knowledge base corresponds to what. So there are no confusions when you are trying to retrieve, or sorry, the information that you are going to get the right result.
Amazing. Thank you, Marcel. We don't have any more questions. I don't know if you want to say something else to the public before uh, we finish the presentation.
Okay. Let me see if I have something else here in the presentation. Okay, we talk about the demo. We show it all. And so yeah, I think we can wrap up what we have covered. We have seen how Bedrock provides a powerful platform for building AI agents that can understand and interact with your business data. Then through knowledge bases, we can give our agents access to our documentation. Then you also have the flows that lets you create sophisticated interaction patterns, and just visually without all this programming of the backend that can get quite complicated. We have also seen how to make these agents accessible through familiar channels that can be WhatsApp in this case. So the experience to the user is seamless. And the most important part, as we spoke before, this is maintaining security and scalability. So, yep, for those interested in exploring further, you can contact us. I think we'll share some contact information, and we can send you more details about the Bedrock documentation, how it works. Also with Vonage, it doesn't have only WhatsApp integration, it has a lot of other services that you can use there. And we have our company blog where we are always sharing technical insights and Amazon news. So feel free to reach us at Circontech if you need help implementing similar solutions for your business. We are here to help.
All right. Thank you, everyone, for joining.
Thank
See
you.
you next time.
See ya.